Okay, welcome everybody. This is Open Research Institute's FPGA and Projects Meetup, and it's the 2nd of December. And we talk about what we have done, what we plan to do, if we have any roadblocks, anything blocking our way, and if we need any resources that ORI can provide. And I will turn the floor over to Everest. Sure, please start us off and let us know how it's going, and got any questions or anything that you need.
Hi, everybody. Happy to get back after a few months. Just following the Opulent Voice chats usually, but don't interact a lot. I see that you try to porting the FPGA to the Libre SDR. It's fine because you have more space on the 7020. I plan to integrate Opulent Voice to the Tezuka firmware. I don't know if you know the project, but it's an easy tool to bring all the stuff to make firmware, and particularly to have some to put it on a SD card instead of flashing at each time you want to test the firmware. So you just need to replace some file on the boot of the SD card, and you can easily test it like that. So I plan to do that. Hope that you, if you put it in a regular PLUTO firmware, and if it's too hard or it's a long time to integrate, I can do it quite quickly. And the other project is Zuccarni Hopper, which is which is a Quipper, Debian based rootfs on the PLUTO itself, so on the Libre SDR itself. And then you have plenty of room, having some Python, for example, and trying to to run as maximum software inside the PLUTO itself. So it could avoid you to use some Raspberry, for example. Well, that's it. Hope that the FPGA, I see that the FPGA side is quite ready, and more and more ready, and it's very good news. Back to you.
Yeah, thank you. Yeah, any way to make firmware more easily is good. What I've done is set up a parallel path inside of the PLUTO MSK repository. So just reusing all of the mechanism that we have with the PLUTO MSK, and then set up I used a lot from HZ12 open source repo on GitHub for the Libre SDR. And that's worked so far. The first goal is to create like a baseline, just the baseline firmware, not our custom code at all. And the only thing remaining is a weird extra word in the directory structure. So when you use the ADI script, that .mk script, it takes any of the argument on the command line and puts it in as as part of the directory chain. This even happens when you're just making the PLUTO firmware. If you say target equal PLUTO, it does that to you as well. So it seems like a bug that's been there the whole time. When you just say make by itself, it makes the PLUTO firmware, and then that's why we've never noticed it before. So having a switch, what I did until today was to say, okay, if you want Pluto firmware, you say target equal Pluto. If you want Libre firmware, target equal Libre, and it's almost working. So what I did is just to say, fine, ADI, you can keep your script the way that you like it, but we're not going to put extra directory names in there. That's not good because then it can't find the XSA file. That's the real problem here, is that when you have all that extra directory stuff, it then cannot find the XSA. This is why people have to move it around manually, which then doesn't work because the make clean will just delete it all. So that's the last thing that I was working on last night and this morning. So I'll go ahead and finish that. But I think we looked at it starts with a T, I don't know how to pronounce it, the Tenegra or the Telestra, maybe the project that you're talking about doing. I think that's probably the way that we'll transition to that. In the meantime, if I can get this working so that we can go ahead and stitch our design into the Libre firmware, then we'll keep moving forward with the old Pluto MSK repository. If you have something better and you're going to do it, good. We can then switch over to that. That's really good news because we've been relying on the Pluto MSK repository for a long time, but there's probably been some updates and some progress and things that are done differently. And I think that's all that I have to report. Is there anything that you have to say, Paul? Because you're working on the processor side. I think you were the one that showed me Everest's directory or the repo. So I'll turn it over to you real quick if you have anything to ask Everest.
Oh, so much. Um, yes, I've been working on the more nuts and bolts procedures, like how to plug it in and how to get it on the network and stuff like that. And I've had difficulty because the default IP address that it assumes conflicts with my local LAN IP address. So I'm trying to use the config.txt file on the mounted directory to uh, to change that, and it doesn't work. It used to work. I've had it work before, and somehow is not working for me today. And I've been trying to figure out exactly how all that mechanism works. Maybe you can help explain it to me. I know there's that file in the what they call the root directory, although it disappears, not even there once you booted the system. Um, you can change that and then eject it, and that's supposed to make it take effect somehow. And I found the scripts, like there's a S45 MSD script, and it runs a script called update.sh, which is a leftover name from when that script only did firmware updates, I guess. Um, and that doesn't work for me at the moment. I think I managed to mess it up. I, it goes through the firmware environment variable mechanism somehow. So it writes a bunch of stuff with FW underscore setenv. And that, I think I messed up. I pulled the plug at the wrong moment once. And that uh, data structure is now, what was then corrupted. And it wouldn't actually write to it. So I went in manually and added and did a setenv on something, and it accepted it and did a um, and now that the complaint about it being corrupted is gone, but it doesn't work. Um, so I can't even boot it right now. I'm gonna have to go back to DFU, I think, or maybe boot from the SD card and uh, and get it back into a working state before I can even try anything else. So does this?
Mm.
Do you understand everything I said, and
Yeah,
do you know what
yeah,
to
yeah,
do?
exactly, exactly. Well, for instance, you try to change the Ethernet, gigabit Ethernet IP address, right?
Well, I was trying to change the USB Ethernet
USB one.
address.
Okay.
But I need both of them to be compatible with my network. I mean, I need the USB one to be different from my network in particular. And
Because your network is on the same subnetwork as the Pluto right now? 190.161.12.xx. Is it your this
Um,
is
there's a couple of different networks floating around here, and
yeah.
recently on these Pluto experiments I've been working on, I've had the Plutos and the Raspberry Pi that host them on USB, not in the remote lab network, but in my personal house network. It seemed like it was going to be more convenient at the time, although that may have been a mistake. Um, so the 168, 192, 168, 2.x network is the default one that the Pluto likes to use,
Yeah.
is also the one I use. Um,
On your network,
yeah,
on your Ethernet network.
yes. Let's
Yeah.
combine Wi-Fi and Ethernet.
Yeah, okay. So, well, the mechanism is quite simple. When you have a USB and you have the config context where you can change the IP address. It is a virtual file. And when you change this file, then there is an event on the Linux, on the Pluto, which get this file, convert it to environment, so FW set env. Okay, so it is written in the flash of the Pluto. And then with this, it uses another script which is S41 network or something like that.
S40 network.
Yeah, which use the environment of the flash to set the interface network. Okay. So instead of using this method with the config context, etc., you can SSH to the Pluto and make some FW set env with what you want. If well, it's for example, if you don't have an USB, because usually now I use all the Pluto, especially with gigabit Ethernet, without any USB connection to the PC. I just SSH on it with a network, with a gigabit network connection. And then if I want to change some environment, I just have some commands like FW set env, which could be USB or IP USB, or I can't remember exactly all the variables, but it is well, I use this more than using the config context, eject, etc. But
Okay, that's useful. Um, or it would have been useful if I'd known it before I completely screwed it up so that I can't even boot it
yeah,
anymore. I'll have to recover it before I can even try that. But so
yeah.
the stuff that I have written in FW setenv is going to appear magically in the new config.txt file, or do I just ignore config.txt from now on?
Uh, well, well, when the config context appear, it use the flash environment, display it. If you modify it, it rewrite it on the flash. Okay.
Okay.
So
And
you
if
can
I,
you can avoid to use this, and you can set it manually, FW set env or FW printf to see what happened. And the other way is that there is a script when on your Pluto on Pluto on Libre SDR, every clone of Pluto, you have GFFS2 mount, which is a flash, how do you call it? Well, it's a flash system, GFFS2, and
file
then
system.
you can have by default it launch a script, and you can modify this script, which is persistent over the reboot. So you can make some environment you like, for example.
Yeah. With the caveat that I discovered a long time ago that
Yeah,
if you let's see what's the system, the problem here. Um, there's some things in the overlay
yeah,
that can override some of that. And for instance, right now, the there's something in our repo that overlays um, the known or authorized hosts file and puts in one secret key or public key that
yeah,
allows one particular login.
yeah.
And anything else that I put in through setin is gone because it's overridden by this overlay. Um, so I've had an issue
Ah,
filed for a long time to remove that overlay so that I can actually control uh, the authorization, but
mm,
it's not gotten around to being installed.
that's another problem because the script which is launched by the GFFS2 is at the end. So the script you mentioned is well, you have an order of scripts and the user script is at the end. So you can't remove the script which remove your key before. So you just need to modify the firmware build and remove this. I think it's on S11 from memory, but I can easily
Yeah, I found
find.
that before. That's no problem. Except that I've been suffering along with it because there's workarounds. I don't need that to be fixed. It just would make it more convenient. I can always type in the password.
Okay.
Um, okay, so that's helpful. Thank you. Um, I This is a matter of entertainment. I went back into the analog devices repo to find out how this got created and how it was all tied together with other files. It's been useful, but what I found was a commit way back when from Michael Henrich, and it's the name of the commit is miscellaneous bag of changes, and it includes all this mechanism.
Yeah, yeah, yeah. That's why. Well, most of the scripts, not all, but a lot of scripts, I rewrite it on the last firmware on the Tezuka and etc. So I have to remember exactly how it was on the ADI repo, but yeah.
Yeah, indeed. And that actually pretty much serves as
I
my
hope
weekly
that
report
I
as well.
hope to include the HDL, well, the FPGA for Tezuka, and you will see that it is very easy after that.
Okay,
Cool.
I'll hold you to that.
Awesome. Yeah. It's been a very interesting week around here with all sorts of discoveries and steps forward. I have a little bit of a report about the HDL. So I can show you why we have decided to just go ahead and move to Libre SDR, which was Everest's recommendation. I think he was the one that said, oh, this is probably out of all the different clones for Pluto SDR, which has been around for a while. Pluto SDR, widely used, but as Everest has pointed out, and we have noticed that you don't get a lot of updates for this. Analog Devices is very interested in some of their other more expensive boards. Understandable. So we have gotten a lot of use and learning and performance and development out of the PLUTO SDR. It's just super convenient in the lab, and it's 7010, very well known zinc chip. But I'm going to show you what the last sort of utilization report. This was the last successful implementation on the PLUTO. This is an image of the implementation inside Vivado, and this is near 100%. It's I think this particular one it's somewhere north of 86%. I didn't run the numbers because it barely fit. And it actually did go ahead and it did actually place en route. But there was a big problem with this build. When we tried to run it over the air, it did not work. We had fixed the transmitter stall, which we found out was because the encoder, particularly the interleaver, was not being implemented. So it wasn't being built, even though we wrote all this great code and it simulated amazing. We kept having this transmitter stall over and over again. So when we went from fake forward error correction, where we're just duplicating the bit, so we have a rate 1/2 forward error correction, convolutional Viterbi NASA encoder. And when we went from just duplicating bits to actually doing real FEC, yes, the utilization went up, but the transmitter stall started. And we thought it was an AXI protocol problem, that it's just stalling. It stalled after exactly 1 frame. The FIFO was filling up, and then everything just halted. So we added some bits to the registers that Matthew had set up for us. We had some unused bits in a register, and I figured out how to add, and we looked at the actual state where it was stalling. It's stalling in the interleaver. We then go and look at the utilization specifically for the interleaver, and it's a very small number of gates. So what ended up being the root cause was a bug. We had a loop in the interleaver that was stopping at 134 bytes. That's not the number of bytes. After forward error correction, you should have 268. So since the loop was not being gotten to completely, the Vivado is very good at optimizing away, getting rid of your logic. If you don't use it in a design, if it's never reached, then it goes away. With this loop bug, half of the interleaver was gone. Interleavers can take a lot of room. So after fixing the bug, it stopped fitting into the PLUTO. Now, this is after going to a simpler interleaver. Your interleaver, you really need it after forward error correction, especially with convolutional encoders. If you use forward error correction and you use a Viterbi encoder, decoder, you need interleaving. Interleaving really helps your error correction. So bit level, each bit gets put in a different location, and it needs to spread out as much as possible because it's to correct burst errors, noise crashes, sudden dropouts. That's the worst thing possible for the Viterbi encoder. So you need an interleaver. That's why we have it. The bit level one, where each bit is spread around as widely as possible. This is widely studied. We know how to do it. That did not fit. So the next compromise up the chain, so to speak, is to do a byte. So you have chunks of 8 bits and you move those around. And that actually did fit. And that's this picture. That solved that problem, but then it stopped receiving. So transmit looked great, except for a weird looking spectrum. We don't know why, but the receiver stopped working. So guess what? Even though we had protected our receiver with don't touch attributes in Vivado, it still doesn't really care. It will ignore those and it will optimize away parts of your receiver. And that's exactly what was happening. So at that point, we've done everything we can to make the design smaller. And we're still looking, this is only hard decisions. These are a hard decision encoder and decoder. So the forward error correction is just black or white, 0, 1. We want soft decisions that we already get this out of the minimum shift keying radio. It already tells us the confidence level of the bit that it demodulated. Matthew already has all of that in there. So we get that for free. The demodulator is providing this information for us. We should absolutely use it. Not just because we already know it, but because it actually gives us a measurable benefit, 2 dB more of SNR or of coding gain. So for K equals 7, length, with the depth of 35, this is all very straight down the middle, good numbers for the forward error correction. You get 2 dB additional gain with soft decisions versus hard. And we want that 2 dB. So we knew already that we needed to put the soft decisions in there, and it requires more resources. We also have a hard decision on the synchronization word, and it's also in the receiver. So when you look for your sync word on every frame, then we just take a Hamming distance calculator. This is a Hamming distance calculation again, it's a hard decision. We really want a correlator. I didn't think that it would be that much more resources to add a correlator, but it's more here, more there. Now we could get rid of a lot of stuff in the design, maybe. We tried. We got rid of the I2C and the SPI peripheral stuff that's in the base design. We got rid of TDD, or time division duplexing, time domain, and we got rid of that because we don't need that for our design. We don't use TDD for Opulent Voice. This did not release enough resources. On paper, you look like you'll get back over 1,000 loots, and you might, but you don't get back the control groups or the control signaling. And the way that these chips are designed, yeah, on paper, it looks like you will release a lot of resources, but in actuality, it does not return that many to you. You always use more than you think when you estimate, and you don't get back as many as you want when you compress your design. We could get rid of a lot of status registers. We could really lower that number by a bit, but it's not really enough to guarantee that we will place en route when the design is properly synthesized, all the stuff in the receiver that's missing, because the receiver never worked. This design, even though it placed and routed and we fixed the transmitter, the design is just too big. We would have to start doing compromises like the byte level interleaver, which is not as high performance as the bit level. Leaves a lot on the table. That's an uncomfortable compromise. If it would get us through working in the lab, great. So anyway, that's like all the big ticket items and all the things that we tried in order to force it to fit in the Pluto. Going from the Pluto to the Libre SDR goes from a 70-10 to a 70-20. We go from almost 18,000 lookup tables to 53,200. So it's a 3x roughly, I think, or maybe exactly, size difference. We will be fine in the 70-20. We may even be able to add things that we haven't thought of yet. So, and it will be very cool. The thing that was scaring us was no documentation. That was scary to hear. But you know what? The documentation from Xilinx and analog devices isn't that great either. So we should not be frightened of this. And so far, I have been able to get the firmware to build with our existing repo and with every's work. If we can get Tezuka to then, and that's a reliable, we could just keep working. Switching to a larger FPGA in terms of the board tecal file, not that different because it's going from a Xilinx chip in a Zinc chip to another Zinc chip. There are some differences. We go from a 225 pin part to a 400 pin part, and adjusting the constraints file took a little bit of work, but it was not that bad. It's documented fairly well, and the Libre SDR people have a schematic, and on one page of the schematic, it had everything that I needed. So that went well. That actually worked. So we've been able to get past all of these things that I was a little scared of pretty quickly. And I think that this is the right time to move to a bigger chip. And having the Libre SDR, it's essentially an updated version of the Pluto. So it is a radio. We get all of the things that we were using on the Pluto in the Libre SDR. We'll be able to do loopback and over-the-air testing in the lab. It's just one box with antennas. It's really good. So we don't have to give up the radio side to make this change. And so that's kind of where we're at. We'll talk about all of this in our next newsletter. So we'll write all this down and put all these pictures in there. And that's like that's the big news from Opulent Voice. I think. Let's see. One last news item about Opulent Voice is that we did get accepted to FOSDEM for a talk, and Everest has agreed to be the in-person presenter. So thank you very, very much for doing that. I'm looking forward to hearing what people ask about and what they think about the work. All right. Any questions on any of that or anything
Great.
you missed?
Great, very, very clear presentation of what the issue with the FPGA size and how to optimize it and how to save some place, which is not always save some place.
Yeah.
Okay, great. And with Tezuka, I support several clones, and the last one is this one, which is called it's called like fishbowl. It's $100 only.
Wow.
7020 FPGA,
Wow.
gigabits SD cards, 1 gigabit of RAM instead of 512 megabytes. Yeah, and some GPIO.
Very good. That's nice.
Yeah, that's very, very nice. And so at this time, even the Pluto is, yeah, the best value of the Pluto is the community and the documentation. But as soon as the clones are mainly done on the same way, and if we can have the schematics, then we can adapt very easily. So each time there is a new board, I think that Tezuka is supporting about 6 different boards: Pluto, Pluto Plus, Libre SDR, Fishbowl. The last one is a very expensive one. I can't remember. But if I can adapt all that with FPGA and firmware, then I don't need all the documentation from ADI. It's a standard one. So I think that we don't have to be scared about the next boards. And ADI is not improving their Pluto platform. They want the firmware is mainly to use the beamforming companion, which is very, very expensive. But on the platform, on the Pluto platform itself, they doesn't have any upgrade. Instead of a very expensive, which called Neptune, which is based not on the AD 9031, but so I think that it's time to have on our own way to develop all that.
Yeah, well said.
That's good.
Yeah, thank you.
And I'm very, very happy to go to FOSDEM and demonstrate Opulent Voice. Hope that I have enough skills to them to show and to present it. But yeah, very happy.
Right on. Thank you.
Could you show that first board again? I wonder if it's the same as this board that I have. I think I purchased this on your recommendation.
Oh, it looks
Um,
similar. That looks very
Yeah,
similar. Yeah.
this is the same. This is the fishbowl one, and this is just the version 2 with GPIO, but it's same.
Cool.
okay,
Awesome. And
good.
that's in Tezuka.
Sorry?
The fishbowl is in Tezuka.
Yeah, exactly.
Right
You
on.
have two repository because there is two fishbowl, 7010 and 7020. So you have two firmware to
Okay.
adapt to
This
that.
one, unfortunately, is a 7010 version.
Yeah. I think that the 20 is maybe $15 more.
Wow.
Yeah, well, now I know.
Oh no, we'll have to get that one too.
We need several of whatever it is we're going to use.
Yeah. Awesome. Yeah, thank you. All right, Matthew, you have the floor and happy birthday.
Yeah, happy birthday.
Oh, thank you. My wife snuck over here and I was not paying attention. Um, very good. Thank you. Oh, very good updates. Yeah, I mean, one other optimization that's potentially there is we could go to one NCO in the transmitter instead of two, but you know, it's 32 registers. We might be able to move some things like the lookup tables into a VRAM. It's massively underutilized for a VRAM, but it would get it out of the LED space. But I think it's, you know, we're wanting to add more and more. It's just going to get tighter and tighter. For example, the block circuits for the Costas loops. So yeah, I think moving to the larger platform makes a lot of sense. So I don't have a lot of updates for this week. I am working on slowly, unfortunately, the lock circuits, which are nice because it not only gives you an indication of lock for the for each Costas loop, but they give an SNR or rather ES over N0 estimate for each loop as well.
Oh, that's
so
going
I
to be
think
great.
Yeah, I think that's nice. So, you know, obviously that's going to take up some more space. And I need to play with a little bit and not just start in VHDL. I want to model it some. And to do that, I'm thinking, and I've started just modeling all the components in Python. And so I have the transmitter almost done and then work into the modulator, because then I can just plug, you know, start modeling the circuit in Python and testing it out in the Python models. And then once I'm comfortable with that, work on converting that into some RTL.
Right on.
So that actually, it's not quite working yet, but I can just show a kind of a fun thing. I can get into the right screen. Here we go. All right. Okay. And so this is just running the modulator, and we can pop in here, you know, real-time graph. So it's graphing the outputs, you know, I channel, Q and Q channel. Well, the top one's mislabeled. So this is the actual output, and then the I channel. Mislabeled everything. Sorry. So the top one's I shouldn't have called it I and Q. That was wrong. F1, F2 is so I need to update this. So the top strip is the output. The second strip is the F1, and the third strip is F2. So I thought that was just kind of fun to be able to plot that in real time. So not much in terms of overall advancing the project, but I think the Python models would be useful, and they can even be incorporated directly into the test bench for the RTL, which is really nice because then you can get basically bit level, you know, sample matching, cycle by cycle matching, bit true matching between a model and the VHDL, which is, you know, very powerful in terms of modeling. If we were to move to an ASIC, you know, this would be what we would need to do in order, you know, to before you want to commit anything to silicon. This is this is the type of work that needs to be done for an ASIC type design. Anyway, so that's just a bit of showing something. So I haven't not done anything, but it's kind of not, you can see the error here. Something's not quite right. But
yeah, it's probably just got one or the other is 180 degrees out.
Yeah, it's just, it should be transitioning at
I mean, it's the right
at
place.
a different point.
Yeah, if you just in your mind, if you just flip it over, it's perfect. That's
Yeah,
really, that's great. And yeah, this is exactly what we'll need for, well, not just for verification or validation, but in order to, well, basically, yeah, this is exactly what we'll need in order to.
As wanting to kind of add some more plots to the strip to kind of match some of the diagrams we've done earlier in the development, so showing how the MSK signals kind of constructed, how the bits are. So there's a blue line I'm showing here that's the bit, bit 1 or 0, right? So we can kind of see how where the bit comes in, how it's working with the waveforms. But I think this can be expanded a little bit, and then it's kind of a nice interactive demonstration of the waveform construction.
Yeah.
So I think from the educational outreach perspective, I think this is a nice thing to have as well.
Yeah, very much so. It's got it shows the switching back and forth, which a lot of people they hear it, but being able to see it happen makes it all come much closer into focus. So yeah, this is great.
All right, so that's kind of all I have for this week, but I'm hoping to get more into the lock circuit. It's based on a particular paper, which I can share if anybody was interested in looking at it. But it's kind of along the lines of where we average out, the values of the kind of the movement, or the average the accumulators and the loop filters, right? And in doing so, then if the accumulators are stable, it's an indication of lock. But the other thing that the circuit has is it looks at the incoming power level to normalize against. Otherwise, the lock circuit doesn't behave kind of as well. So it has some nice features that should help, be very stable in our environment.
Cool. Okay. Yeah. If I think people would really like to hear like here's this paper, and then we're going to implement it. And I think that would be really nice. Just it doesn't have to be like a complicated article for the newsletter, but I think that would be a really good thing to add for the next one going out. So yeah, a couple of paragraphs, and then the citation of the paper would be of great interest.
Great. Yeah.
Awesome. Good. All right. Any other questions, comments, work, victories, defeats?
Just a quick question, because maybe I missed some development. Right now, the MSK output is IQ, right? Which means at the time you developed the HDL to have only I and not IQ. Is it now the case, or?
Yeah, it is IQ now.
Okay.
It wasn't clear to me at first how to do it, but in the end, all I do is put the NCO phase value into a sine lookup table and a cosine lookup table, and output is I and Q. And it works because it does cancel the other image after we mix up. So it's working as we would expect as an IQ output.
Okay, great. Second question: when you takes, what is the output of the what is the native output of the AD9061? Which means that I think that you run it at very high sample rate, and then in HDL you reduce it just to have the bandwidth of Opulent Voice. But it seems that you don't use low sample rate, for example, four mega samples. I think you are at 32 or something like that.
Yeah, what we're getting to and from the 9361, 9363 is 66 megasamples per second. In the transmitter, there's no memory in the transmitter. There's no, not necessarily reason to slow it down because the transmitter can generate samples at that rate. So it does. The only reason you might want to slow it down is you could save some power because you're not toggling as often. But then in the receiver, yeah, there was some indication, and somebody was helping previously, and horrible names, sorry, but he was looking at some of the loop math and had concluded and suggested that the high sample rate was maybe making the loops unstable. So what we did is we're running the loops now in the receiver about 2.5 megasamples per second. And how we're doing that currently is we're just basically throwing away, like, there's a ratio and a number in the calculation, but it's like 25 samples we throw away. And so then we take every 26th sample or whatever the right number is. Now that's fine almost, but it's really a poor man's decimator in that if there was any other thing in the input bandwidth, it would alias in, right? Because we're not doing a proper low pass filter now. So that's something actually that
That will stop.
I think he froze. Yeah.
Yeah.
Who froze?
Oh, you did very briefly.
Oh, okay. Oh, yeah. Now it says my
Seconds.
stable connection's unstable.
Yeah. Yeah. So I think you were telling us about the what you wanted to do. So you got right
Yeah.
up to the point where you were actually going to say what, and then
Yeah. Well, I was just saying we need to put a low pass filter in before we do the sample tossing, right? So that we eliminate anything that might be in that bandwidth that would alias into our much narrower bandwidth after we've tossed those samples. So yeah, that's something else that would take more space to design in the FPGA, right? Yeah, and there's multiple ways we could do that, cascading some half band filters, or but in this case I might be just inclined to just put a deep low pass filter in front of it and then toss the samples.
yeah, I think
Okay.
that's within our capabilities.
Yeah. Now, but it's okay, no, we're doing the encoding and decoding on the bit side. So yeah, that doesn't have, the sample rate doesn't really affect that at all.
Okay.
So the thing is of interest is that the receiver is still actually running at 66 megahertz at the sample rate, but we're basically enabling the receiver to work every 26th sample, right? So we're basically creating a clock enable. So even though the clock rate is still 66, the effective rate of the receiver, right, is only like 2.5 megahertz or whatever it is that we're whatever that ratio was.
So you mean that the ADC is running at 60 megasample, right?
Right.
Okay. Of course, there is always some reason, some good reason. Having 60 mega sample could a good thing is that you can have an NCO to go through all the frequency you want over the 60 megahertz band. But at the same time, if you don't want to choose the channel over this high band, as you reducing the sample rate using the ADC and the decimation of the AD 9361. If you use the decimation, then you have low noise. So I think it's maybe better to use the decimation of the ADC and then having less down sample at your side, because you will gain some noise on the decimation stage before.
Yeah, I mean, I agree. I mean, we only need, less than megahertz of bandwidth, and so now we have nearly 66 megahertz of bandwidth, right?
Yeah.
If INQ, assuming it's INQ. So, yeah, I mean, it's massively overkill. But it's not that we didn't want to do it another way. This was just kind of expedient to get us up and running, right? So I think there's a lot of system analysis, system design that we need to step back and re-review, right? So again, part of it, the 89363 runs natively at 66 in the Pluto environment. So I didn't want to mess with that, figure out how to mess with the 9363. It was just easier to toss samples. It's not the right way in a production system, right? But it was expedient to get us up and running and working in the lab. So yeah, that needs to be revisited, and we can certainly optimize sample rates and filtering, and maybe even a match filter, because it's a simple waveform, which would help with ACI and noise. So there's a lot of things we can look at to improve the system performance.
Yeah, maybe I can, if we don't already have it as an issue in the repository, then I'll add it so that we don't forget about it.
Do we want to move the issues? I'm sorry. I just had, are we wanting to move the issues from the Trello card into the repository?
Yeah, that might be a good idea.
It's probably more accessible to people if they come to the project and maybe want to see something they want to try and contribute to. That it's Trello's kind of, you have to know it's there, maybe.
Yeah, you do. You have to notice, like, go on our Slack. So that means you have to ask, like, yeah, I want to join your project, and I want to join essentially your server, the Slack workspace, and then see that it's a pinned thing. It's really neat. I'm glad we have it. It's we get it for free as a nonprofit, but pretty much anybody can find the GitHub, and the issue tracker there is pretty good. We've relied on it very heavily for Interlocutor to keep track of all the wouldn't be nice to, or things that we need to fix, or systems level stuff. So should probably add the managing the ADC rate. Lots of benefits there, and we're aware of them, but it was I didn't want to tangle with it either. But now we know a lot more. I think this is coming into focus as something that we can resolve with, especially going to the new larger chip. Now gives us a chance to do these things. So yeah, adding the Trello issues, moving them over to the GitHub would be, at least copying them over would be a real good idea. That'll keep things in focus.
Yeah, I'll work on some of those, because they could probably be cleaned up and stated better. And because I was kind of using Trello as a bit of a scratch pad.
Okay, yeah, that's fair. That's good. Yeah, thanks. Please proceed. Awesome. All right. Any other questions or comments?
I've got some.
Go ahead.
It occurs to me it's been a few weeks since we had one of these meetings, so maybe we haven't talked much about Dialogus improvements, and we've been getting closer to a usable system by little baby steps. And there's a couple of different things that have changed. One is that it's now switchable between doing all the processing in software, although it's not all implemented yet, and the current way forward, which is doing all the processing in the FPGA, which is a slightly different set of requirements for Dialogus. And having reached that point, I also finally put in the encapsulation interface for received frames. So for a little while, we had receiving frames that seemed to work, and I was able to actually interface with Interlocutor and have conversations going all the way across, which is a milestone. I didn't do it with voice yet because it was easier to debug with short text messages. and then we end up with some problems. We couldn't pass data through anymore. So I haven't made any further progress on that because of the problems in the FPGA. But this all leads me to a question that I want to ask of Matthew. Um, the TX sync control and TX sync count register, which I think of as a preamble generator. Um, I need to know how that works. If I put in um, turn on the sync generator and
Oh,
get
okay.
on, then turn on push to talk, which is really transmit enable. Um, it does it start up? It starts up right away and does the number that I specified in the count, and then what happens? Do I have to have the the actual transmit data, the first frame of transmit data already in the queue and ready to go so that it can switch over automatically? Or
Yeah, as soon
what's
as the sync symbols have been transmitted, the number, the counter, right? So once that counter is expired, it will immediately switch to trying to transmit TX data.
okay. And
Now
if
that
it
could be changed if there's something that's would be useful, a different way to do it. But right now that's what it's.
okay. So I think there's a problem with my current implementation. I may need to hold off on push to talk until the right time, depending on how big the count is. When I was generating preamble in software, I could only generate it in one frame chunks. So I always had a giant 40 millisecond preamble, um, which and my timeline is kind of designed around that. Um, Now going into uh, generating preamble and everything else in the FPGA, which is, I think those go together. I can't generate the preamble by hand once I give up modulation and all that encoding stuff to the FPGA. Then we are free to choose whatever like the preamble we want. And if 40 milliseconds is too much, what almost certainly is, at least I hope it is, then we can turn it down to a much shorter preamble easily just by changing this register. But I have to make sure my timeline can accommodate that. So I'll have to, once I get a frame from interlocutor, I being dialogus, um, I will have to wait until such a time that I can start the preamble and still be assured that the next frame will be arriving in time to fill in. Um, so I can't be quite as reactive as I am now. I can't just go ahead and start the transmitter as soon as I know that there's data coming in. I'm not sure there's any way to
Well,
fix that because this has to be causal, right? It can't predict the future.
well, I mean, one way we could change it, right, is um, say you turn on the transmitter, and I assume that you haven't put something in yet, right? Is there something in the buffer where you turn in the transmitter on before you put something in the buffer?
I'm, I I can't do that as far as I know. I turn it on and then start loading stuff up.
Okay, so you're turning on first, so that the transmitter is trying to transmit something. Let's say we don't have the sync even, right? So then the transmitter is just pulling something from the FIFO. The FIFO is empty. There's nothing in it, so it's pulling zero. So it's just sending kind of a, just a, an idle waveform, if you will. It's just sending the same bit over and over, right? And then when something finally comes in, a packet comes in, then it's pulling that out and it's going to start transmitting the data in that packet, right? What we could do potentially is we we know that the FIFO has data in it or not. So when you do the PTT, we could basically not send a sync until some data arrives into the FIFO, right? And then once that data is in the FIFO, we could send the sync signal that the RTL generates, right? And then when that's complete, we can start sending the data that's in the FIFO.
Yeah, that almost works. That sounds nice, but I'm trying to accommodate um, a maximum amount of jitter in the arrival time of the data frames, and
Mm-hmm.
because of the desire to have the interlocutor be possibly in a different location than the transmitter, including Dialogus. So
But
if
that shouldn't really generate any jitter, right? You're just adding some latency, I think. But once you've because you're only transmitting that sync pattern the first time you assert PTT, right? So as long as the PTT is enabled for, you know, all the packets you're transmitting, you're not going to be adding any jitter to those packets, right? You're just adding latency to when you send the first packet out.
yeah, but I may not be adding enough latency is the point that um, I can't assume that the packets are going to arrive at exactly 40 milliseconds apart. That's what I mean by jitter. So
Oh,
if
you mean into the FIFO?
no
Into the transmit FIFO?
in even earlier than that, if they arrive over the interface between interlocutor and dialogus, in other words, on the USB port of the Pluto, um, if they arrive there with some arrival time jitter, which they will, because it's a network, then I have to accommodate that. And if the first one arrives a little early and the next one arrives a little late, then I've got a gap.
Right,
And
but I mean, I guess if you could set a minimum fill level of the FIFO, right? So that you don't that you use the FIFO also gives you elasticity for this kind of thing, right? So if you said I don't know, say we have a I haven't looked, I'm sorry, at what the depths are currently, but say you had a 512 feet FIFO, you could set a minimum fill level of say 128, right? So you wouldn't send the first bit until you had 128 bytes in the FIFO, right? And then, depending on the transmit rate, if you had a certain amount of gap, the FIFO would tend to empty. But then when you got that next packet, it would fill up again. And so you kind of would average around the 128 fill level that you said. Um, but that
yeah,
way you prevent any gaps in the packets going out over the air.
that's right. And that's exactly the scheme, but it's not just an arbitrary number that's picked because it sounds nice. It has to be like to get the optimum amount of jitter uh, tolerance on the arrival time of the frames, it has to be half a frame. So
Okay, I mean, yeah, I mean, so the minimum fill level that you're going to set the FIFO at is, yeah, it's determined. I mean, we have to do like a system analysis and say it needs to be this, and then we can test it. And if we're underflowing, then we can add more. But I mean, we should if we have some bound on the gaps between the packets, then that bound can inform us as to what that minimum fill level for the FIFO is. Now, if it's unbounded, yeah, that's a problem.
Yeah, but
So
we can't expect to cover every case of weird packet delivery for remote radio. So there is definitely a limit. Fortunately, the test bench that we are currently using for end to end, we can manipulate all of this and test it and show what happens to all the FIFOs. So we can get this number from the test bench that we have. Um, and and we can look at actual network numbers and say, okay, what do we want to accommodate? You know, most like this program that we're using today will just simply cut you off. It did to you earlier when you had unstable network condition. It basically dropped the call and then reestablished it a little bit later. So I don't think we should think about this in terms of heroics, but we can do enough elasticity where a typical connection, the person on the other end of the radio will never know that the packets were arriving and looking wiggly with respect to time. So we can get the answer. I'm not too worried about that. We already know that we can accommodate packets just slamming in. You could dump an entire huge file on us and we're going to be okay. It's the other side where packets are delayed. They get further and further apart, and we can absorb up to the amount that we pre-stage. So we're allowing a little bit extra. It is a overall latency. We'll give you like half, 20, we're talking like 20 milliseconds of extra latency. So far, we have a pretty low latency system. We've tried to keep that in mind the whole time. But an extra 20 milliseconds in order to say that we can accommodate a kind of a jittery internet connection is not a bad trade-off.
yeah, unfortunately, we have no way of characterizing the jitteriness of the internet connection. We can
Well,
only
I mean,
set a goal.
we just have to put a bound on it, right? What we think is reasonable, and then we have to have mechanisms in place to recover if the packet didn't come in time. So that, I mean, that might be something we need to look at. I'm sorry, I have another meeting I need to join, so I'll have to say
Okay.
goodbye. But it was
Yeah,
a good conversation. It'd be good to continue this. These are really interesting problems, actually, in terms of packet arrival times, and even network QoS and all kinds of
Oh yeah.
stuff that anyway. So
Cool.
all right.
Yeah.
Talk to you guys later then.
Thank you,
Yeah, I
Matthew.
think we'll shut down because we're just a few minutes over our usual time. Thank you everybody for hanging in there. And we'll meet again on the 9th. December 9th will be our next meeting, and then we're going to take off for the holiday. We'll be back January 6th for the meetings, but we'll be on Slack and email and all that. So we'll take a little break. We'll be here next week, and that'll be the last one for the year. So a very good year. Lots of stuff going on. Next week will be very interesting. We'll work hard on all of these things. And thank you to everybody. All right. So
Thank you.
see you next week.
Thank you.